So the next type of transformation and special transformation that we're going to do is look at what happens when we do reciprocal functions. So we've done a basic reciprocal function as one of our parent graphs in transformations. So you might remember the graph of 1 over x, and we did transformations with that. What we're going to look at today is what happens when you put any function underneath a 1 over. So you could have 1 over the square root of x, or what would it look like to have 1 over x cubed, or 1 over x squared minus 4. And so we're going to look at what are the steps that we need to do to graph any reciprocal graph. Now in grade 11, you did all of the 1 over parabola ones. So we'll review some of those, but we're going to extend it and say we can do reciprocal graphs of any function if we start to look for some patterns. So the first set of notes that I handed out for you talks about what are some of those special patterns that happen. Now, on an easy, really relatively simple way to explain it, all the 1 over f of x graph does is it changes your y values from the function on the bottom to 1 over y. So if you had, what we're going to do is we're going to graph the original function on the bottom, just look at the y values and change them to 1 over y. And that seems relatively simple, but the problem with the reciprocal graphs is some crazy things happen. We have a lot of non-permissible values and asymptotes, and the graph ends up looking really strange at the end. So what we're going to do is steps. So I'll talk about the steps here briefly. We'll do an example and you'll see how they work. But what we're going to do when we recognize that we have a 1 over f of x graph is we're always going to draw the graph on the bottom first. And the graph on the bottom is going to be a graph that we have the skills to graph. Then once we've seen our original graph, we're going to look at where the original graph has x-intercepts. Okay, so I'm just going to have, it's so much easier to see with an example. Let's say I have a parabola like this. That's my f of x graph. Wherever I have x-intercepts, what are the y values at those points? 0. So it could be, I mean, I don't know exactly, but maybe this is 2, 0 and negative 2, 0. And if the main rule of a reciprocal graph is this, that you change any point, you just change the y value to 1 over y, what happens when my y value is 0? And I change it to 1 over 0. That's going to be bad, right? That's going to be a non-permissible value. So the first thing we're going to look at for a reciprocal graph is any time that our original graph had x-intercepts, we're going to draw asymptotes. So step 1, we're going to look at our original graph and we're going to draw asymptotes. Step 2, this is step 3. We're going to look at our original graph, and if our original graph y values get really big, either big positive values or big negative values, then we're also going to have an asymptote at y equals 0. Again, look at my parabola. Can you see that that green parabola goes up forever? Okay, so I'm going to have some points, like here it looks like I might have 3, 5. What's going to happen to that point when you do the reciprocal? The y value is going to change from 5 to 1 over 5, and it's going to get small. And as the y values get bigger, 1 over your y value is going to get smaller. So I think I have an example here saying if you had the point 100, 10,000 on your original graph, then that point becomes 100, 1 over 10,000, really, really small. And so we will get an asymptote at y equals 0, a horizontal asymptote. This one, I'm going to change the wording of it a little bit. What I would like to do is add the word nice points. You don't necessarily have to do where it's equal to 1. But if you have a nice point, then you can just change the y value to 1 over y. And you'll see when we do our examples what each of these steps looks like. So any nice points, you can just change them, the y value to 1 over y. And this is step 4. Step 4 and 5 together, you can put them together as just nice points. So if you've got some nice points, change them. But what it's trying to say that if you have a maximum, maximums become minimums, and minimums become maximums on reciprocals. And then finally, once you've done all the nice points, we draw something called asymptotic behavior. So we've got our points, we've got our asymptotes, so you'll draw your graph towards the asymptotes. So on the next set of handouts that I've given you, I've got a bunch of examples, and each step is drawn out one by one. If you were doing this question, you wouldn't draw each step out separately. So what we'll do is we'll look at how you would graph this if you were doing it on a test or a quiz. So the first one, 1 over x squared minus 4. This is a question right from grade 11 because it's 1 over a parabola. So the first thing that we're going to do is we're going to draw our original graph. So here's our original parabola. It's a parabola that's been shifted down 4 units. So you know that your vertex is at 0, negative 4. You've got an x-intercept at 2, 0, and negative 2, comma 0. If you wanted to label some other points on there, you could. For example, if you plug in 1, you'll get 1, comma, negative 3. If I plugged in 3, I would get 3, comma, 5. So there's a number of nice points on this graph. When we go to draw our reciprocal graph, the first thing that we're going to do, which is steps 2 and 3, you can kind of combine those just to think about asymptotes. So the first thing you're going to graph with the reciprocal graph are your asymptotes. Wherever you have x-intercepts to begin with, if you're changing the y value to 1 over y, those will be non-permissible values. So at 2 and negative 2, you'll draw asymptotes. And when y equals 0, you'll draw a horizontal asymptote. Because your graph keeps getting bigger and bigger and bigger, you will have a horizontal asymptote at y equals 0. So draw your original graph, and then steps 2 and 3, which if you like to remember things shorter, you can just think asymptotes. Draw your asymptotes next. After drawing your asymptotes, you can plot all the nice points that you have. So what's going to happen to 0, negative 4? 0, negative 1 over 4. All we do is take our y value and do 1 over that. 1, comma, negative 3 will change to 1, comma, 1 over negative 3. What's going to happen to 3, comma, 5? 3 comma 1 over 5. And what you're going to want to do is to have nice points labeled in each section that your domain is broken up by your vertical asymptotes. So in this one, do you see I have a point to the right of x equals 2. I have points in between x equals negative 2 and 2. I need to have a point to the left of x equals negative 2. So is there a nice point on this graph? I've got negative 3 comma 5 as well. So on my graph, I can label negative 3, 1 over 5. Once you have points in each of your sections, the last step said draw the asymptotic behavior. That means in this section, if I have this point, it's going to go towards my asymptotes. In this section, it's going to go towards my asymptotes. In this section, the graph is going to go towards my asymptotes. And there's our final graph. So what's hard about reciprocal graphs is your final graph looks really different than your original graph. Okay? Did you, oh yeah, you named that one sad clown face or something like that? Exactly. Okay, perfect. There's example 1. Example 2, 1 over x squared plus 1. So we draw our original graph. There's our original graph. It's a parabola that's been shifted up 1 unit. So you would have the point 0 comma 1. We have some other nice points we could label on there. 1 comma 2, 2 comma 5. We can label by symmetry the ones on the other side as well. So first thing, draw the original graph. Second is your asymptotes. We will have asymptotes wherever we have x-intercepts. Are there any x-intercepts on this graph? No. So this graph will have no vertical asymptotes. However, does this graph go up forever? Yes, it does. So then we will have a horizontal asymptote at y equals 0. So if you have a horizontal asymptote for a reciprocal graph, a 1 over graph, it'll always be at y equals 0. Do we have any nice points?
0, 1.
What's going to happen to 0, 1?
Nothing. It's an invariant point.
It stays the same because you do 1 over 1. What happens to 1 comma 2?
1 over 1 happens.
1 comma 1 over 2. What happens to 2 comma 5? 2 comma 1 over 5. And similarly, we would have negative 1 comma 1 over 2 and negative 2 comma 1 over 5. So we've got a bunch of points labeled. The last thing we need to do is show it towards the asymptote. And there's our final graph. What did you call this one?
A speed bump.
A speed bump. So those first two were review questions from grade 11 because they were 1 over parabolas. But now what we're doing in grade 12 is we say we can do 1 over any graph if we follow these same ideas. So here we have the graph of 1 over the square root of x plus 4. If you graph the bottom, that's just your square root graph moved 4 to the left. So we have the point negative 4 comma 0, negative 3 comma 1, 0 comma 2. You could plot some more points if you wanted to as well. Taking those points then, we could draw our reciprocal graph. Do we have any x-intercepts?
Yes.
We have an x-intercept at negative 4. So we'll have a vertical asymptote at -4. Does our graph go up forever? Yes, it does get bigger and bigger, so you will have an asymptote at y equals 0. Now just take your nice points. What's going to happen to 0, 2? 0, 1 over 2. What's going to happen to -3, 1? It's going to change to -3, 1 over 1, which stays the same as -3, 1. If you wanted to find another point on here that was nice, what's another nice point on square root of x plus 4? We've got that point already.
1 over 2.
I don't want any fractions. What would be another nice point on there? 5 and 3. Perfect. Because when you plug in 5, you're going to get the square root of 9, and the square root of 9 is 3. So we're going to have the point 5, 1 over 3. So all we're doing is taking our y values and going 1 over them. But we have to add in the fact that sometimes you're going to have non-permissible values. And we're also adding in the fact that if your y values get really, really big, huge numbers, either positive or negative, we have an asymptote at y equals 0. But after we've done 1 over y and we've got some points, this part of the graph is going to look like this. Do we have anything on this part of the graph? No. Okay, we don't because our original graph didn't have anything to the left of -4. So our reciprocal graph also won't have anything to the left of -4. And finally, what I find the exam really likes to do is just make up some random points, join them together, and then ask you to do the reciprocal graph of that. So in some cases, this is even easier because we don't have to do step 1 because they've done step 1 for us. They've drawn the graph for us. All we need to do is draw our reciprocal graph beside it. So when drawing the reciprocal graph, the first thing we look at is our asymptotes. Do we have any x-intercepts? We have one there, and one there. So we're going to have asymptotes at -1, 2, and 5. So at x equals -1, x equals 2, and x equals 5. Now looking at the left side of my graph, do you see that it doesn't go up or down forever? It just stops there. But looking at the right side of my graph, there is an arrowhead pointing that it keeps going bigger and bigger. So because of that, we will have a horizontal asymptote at y equals 0. Asymptotes are done. Do we have some nice points? Yes. What's going to happen to -5, -1? It's going to stay there. 2, 3, 4, 5. What's going to happen to -2, -1? Also going to stay. 0, 1 is going to stay. 4, -1 is going to stay. And 6, 1 is going to stay. Any time that your y values are 1 or -1, they stay the same because you do 1 over that. Yeah, let's see what happens. So the question is, after it goes from this point to this point, does it go up or does it go down? Okay, it's going to go down. And the one way, if you wanted to, you could take another point here, say that green point. Can you see the green point there looks like it has a y value of a half? If you did the reciprocal of a half, if you flip that fraction, you would get, or sorry, it'd be negative a half, right? Because it's below the x-axis. If you did the reciprocal of negative a half, you'd get negative 2 over 1. And so by just taking an extra point like that, we're like, oh, so it does go down towards that asymptote. And same thing here, we could take values here and here, the y value would be positive a half. If you did the reciprocal of positive a half, you would get 2 over 1. And so that tells us that in this section, our graph is going up towards our asymptotes. Same thing here. If we wanted, we could figure out here are places where the y value is negative a half. So it's going to be negative 2 in those sections. So we can draw our asymptotic behavior. Notice that we did not put an arrowhead on the end of this point here. Our original graph stopped there, so our reciprocal graph stops there as well. But we did put arrowheads on the right because our graph continued forever on the right.
And everything else, right?
Yeah.
Would the inverse of a sine wave, the reciprocal of a sine wave be something like that?
We're going to do the reciprocals of sine, cos, and cotangent tomorrow. But today we're just starting reciprocal graphs. So our quiz tomorrow isn't very long, so we'll be able to do that after our quiz.